Hi everyone. I haven't shared the 3D workshop that we had on Saturday. I'm gonna share it with you. And we had I think Tatiana won the little 3D toy. I don't think she's connected yet, but we'll get ready to start. Are you? Let me see. Let me share my screen, and you guys let me know if you can see my screen. Okay, guys, we are about 27 participants, so we're about to start, and I'm gonna share my screen. I hope your evening is going great. Over here, it's a little bit hot, but I got a soda, and hopefully it'll be a little bit cooler. Let me start sharing my screen. Let me know when you see it. I got a lot of highs comments. Thank you guys. Hi to everyone. And put it number 1. Okay, today my computer is working good, so I hope it behaves through the whole thing. And you guys are able to see my screen? Cool. Thank you, Ramya. Cool, Ori. Okay, so we talked about on Saturday about 3D modeling, and David gave us a workshop that most of you guys attended. So, and he talked about 3D modeling fundamentals as a very important part of it. If you guys wanted to design anything on a 3D space, so I thought it was very important to start from the basics. So what's a modeling? So a modeling means to represent. And whenever we talk about a 3D, we are representing a three-dimensional geometrical model of an object surface. That means you have an XY, an X, a Y, and a Z plane. So you're drawing in 3 planes. So you have, if you're gonna have your square, you're gonna have a depth, which that'll be your Z or your X or your Y. You're gonna have 3 axes. And I got this from 3D modeling. And basically 3D modeling can be described as the process of creating a digital version of an object surface. It doesn't matter if it's real or it came out of your imagination. So I have a question for you guys. Will traditional artists make a much better 3D modeler? What do you think? Is that a myth or is reality? Will a traditional artist make a much better 3D modeling? What do you think? Yes, no, maybe? Toby says no. Francesca says yes. I really don't know. I think it depends. Some people say yes, some people say no. But I just wanted to say as a point of discussion, I think it does make a better 3D modeling. There's not a right or wrong answer, but what it's a myth, it's my next question. Is it required to study 4 years in a fine art department to be a 3D modeler? What do you think? Yeah, Ramja, Benicio, Just, they say no. I agree with them. Ori says no. I think it does not require a 4-year degree on a fine art department to be a 3D modeler. As David said on the workshop, once you know the basic of drawing by hand, a 2D, then it will become really easy for you to become a 3D modeler. Once you're a 3D modeler, it's just a matter of experience. It's just a matter to exposure to the tools. That way you'll be faster at creating something. It doesn't matter if you create a surface like this or a phone like this. It will just be the same concept. So we're gonna go through the basics today. So the basics, these are the basics. This is kind of like the Bible for any, when you're gonna start. So we have the elements of design and the principles of design. So the elements of design, that's the tools to make an art. So whenever you're gonna create something, this is the tools that you're gonna use. You're gonna use the line, you're gonna use the line will be just the outline. Over here you can see it's just like the outline of the little doll, the shape, the form, the color. It's gonna have a texture, the space, the area around it, and the value, like the darkness, the light, the intensity. And then you have the principles of design. What are you gonna make with that line? Are you gonna make a pattern? Are you gonna make a contrast, emphasis, balance? Proportion is really important, harmony, grace, and movement. So we're gonna go through some of them. This is another elements of design. This is just a quick reference. That way you'll have your line, your shape, your color, your size, the intensity or value, and the space or proportion that you're gonna draw. So let's start. So what do we mean by reference? So reference is the more familiar you are with the object, the easier will be to reproduce. So for example, whenever you're gonna take a picture or photograph, what do they do whenever they're gonna get a picture? They observe. They observe until they get the perfect picture. So I recommend you to, like, once you're gonna start drawing any object, if you get to touch it, to observe it, then your mind starts thinking on how are you gonna start drawing it. So that's what they mean by reference. The more familiar you are with the object, the easier it'll be for you to reference. Another important part will be proportion. So sometimes you could have a great design, a lot of details, but then once someone else look at it and they say, oh no, he missed a little detail because the eyes in relation to the face, they're out of proportion. Let's see. So they always say proportion, proportion, and proportion. So I put here a quick example of kind of like a wine bottle and a wine glass. So you start seeing, you start dividing like the size. Like, for example, the size of the phone or the size of a cup. Okay, so this will be 2 times my hand, or that's what they reference about proportion. You start with one baseline on, usually it's on inches or in millimeters, or you could create your own, like one square will equal to that amount. So that's what they mean. So how to get the proportions right? So this will be, the more familiar you are at making comparisons, the easier it'll be for you to start drawing. So any progress you do or the more you know how to draw in 2D, the easier it'll be for you to draw in 3D. So it'll reflect. So the more you practice drawing by hand, the easier will be for you to get the proportions right. So the same I'll recommend is observation. And then once you observe something, your brain starts thinking and comparing one thing to another one. If you are drawing like the wine and then the cup of the 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 cup of glass, or the glass for the wine, your mind start comparing the diameter of the bottle with the diameter of the cup, and the length and the depth. So the more familiar you are, the easier it'll become. So I have here a quick kind of like reference. If, like, as I was saying, you could either measure it by inches, by millimeters, or you could have, like, for example, here, your clip, or like a paper clip, and you can say, okay, my pencil is 3 paper clips or 5 paper clips, or the shorter, like your crayon is shorter than the pencil. You start referencing other components and comparing one to another one to get your proportions right. So it has to compare to something. So you think about, I just put here a quick image. So let's do a quick exercise. You guys have a pen and a pencil? Or something. It doesn't have to be, so I want you to draw on a piece of paper some dots, like in the picture that you're seeing. So randomly. Some bigger, some smaller. It could be 2 or 3. Or it could be like me, like I draw 15. Let me know when you're ready. Okay, so now, well, how will you start if I tell you, okay? Now draw the same dots on this sheet. You're gonna start observing these dots, and maybe you're gonna start referencing them. For example, this one, if I have a measuring, I don't have a ruler, or I could have started with a ruler, but if I don't have a ruler, I would say, okay, I have this pen, and then I could start, okay, from here to here is this size, and then from here to here, it'll be here. So from here to here, it'll be here. And then from here to here will be until here. So from here to here will be until here. So all of the, like me as a product development specialist and technical designers, they have the calipers or a measuring tool. We use it almost every day, every time. You kind of like are measuring, comparing, referencing, because we have to measure, we are comparing it to a prototype. So the designer will create a design and we have to make it manufacturable. So once we have it, then we start referencing like, okay, how big are the eyes? How big are the feet? How big is the proportion overall? Like if we have a design, we try to take basic dimensions from top to bottom, width, length. So those are always good, kind of like referencing your measurements. Okay. And then you start referencing from this point to, if you want to draw this one, it's at an angle, so you can like replicate that. So that's how you go about it. It's just a quick example just to get your mind thinking. So if I ask you guys to draw this image that I found on Google, how will you start? So you'll start by observing the picture, measuring how much, or start by dividing. So I have a, start dividing by lines. Let me see. Sorry, I had one image on top of the other one. So I hope this will make it better. Okay. Sorry about that. Okay. So if we have this picture and we were about to draw it, we're probably gonna start dividing the picture into squares or into triangles from corner to corner, from center to center. That way we'll start seeing where we can start drawing it. But then once we divide it, we could do the same with this. We say, okay, we could start dividing it by corner to corner. And then center to center. It's okay, none of them fit here. What about in the center? So we got one right at the center. So this is how you'll start. Also, you could start like that. And then we start joining the edges and the outline. And you get more, you start getting into more detail, and you can like start measuring from the edge of the picture to half, and then, so that's how we go about starting to draw. So from here, once you have all your measurements, then you start creating more detail, lines, points, and more of a correct dimension. So another good one is composition. The composition refers to the, how do you arrange the objects? How is your combination of the objects that you're making? You want to bring the eyes of the viewer towards the center. So sometimes you see pictures that the main point is right at the corner. So it depends on what you want the focus to be at. So once you have the focus, then it's about arranging the objects in the space that you have. That way it's gonna have a balance of the 3D objects that you're creating. So everything in life can be broken down into smaller forms like spheres, cones, cylinders, and boxes. If you can draw these basic shapes in every perspective, then you can reconstruct anything. I like that. I like how they draw here, kind of like basic shapes. Starts with a cylinder, a square. I don't think they have a square, but this is our very organic shapes. So if we start with 3D, we could always, it's easier to start kind of like with a sphere, with a cone, with a rectangle, giving it some depth, and then creating surfaces around it or combining them. So we go bigger and then we go smaller into the details. So there are a lot of techniques on how to draw different structure, scene, perception. There are also a lot of exercise on contours, gesture drawing, or making cartoons. So if I will recommend, these are just kind of like the basics that I wanted to cover with you before we move in, like just wanted to show you the basic of 2D, and then we can move how does those apply to 3D. But there are a lot of good books and good techniques out there. I think I have, yeah, these are some books that I put. The New Drawing on the Right Side of the Brain by Betty Edwards, The Natural Way to Draw, The Practice and Science of Drawing. You might find them in the library too. They're free. And you can start I put a horse upside down and see if you could be able to draw it upside down. Try to start making your brain think as objects. Try to make your brain think in a 3D perspective, or start training your brain how to think, how to extract something that is out there, something that is already created, and then try to put it in paper. Those are some quick exercise that you could learn. That way, whenever you go to 3D, it'll be easier to understand the tools that they're out there. As David said on Saturday, the 3D part is just a tool. The 2D part will really help you understand how to build things faster and easier with the 3D tools or features. So how is proportion in 3D? Proportion will be close to imagining or drawing from your imagination. So once you're gonna first start with a 2D line or a 2D object, and then adding some depth to it. That will make it 3D. So start drawing in a third dimension. So proportion is really important in 3D also, because the objects that you see in your screen, you see them at a very detailed perspective. So you could zoom in very close. Even if you're gonna draw like an aircraft that is really big, you could zoom in and lose the self of proportion really quick. So that way well, all the programs, they have like a grid that you could assign to it, like if it's in inches or millimeters. And that way you always start drawing with proportion. All of them are based on dimensions. Like you give a dimension to your line, you could give a dimension to your tool. And as we saw on Saturday, like they have different colors, like blue. I don't know if you remember the first kind of like line that David drew. It was kind of like blue, meaning like you could still move it. It's not locked. Once you give dimensions to all of the line that you're drawing, then it's locked, and it's easier just to create some depth or a 3D object. And as I said before, practice will help you out to understand better and be faster at what you're trying, or at translating what you want, what you have in your mind, to translating into paper or into a physical object. And measurement is another element that I put here 2 images. That one, you are able to place, for example, here is a human body, that way, or a silhouette. That way you are able to have a better perspective of your proportion and your measurement. Like on the right, it has a dimension. That way you are not creating something that's really small or really big. Like you can assign how long you want it, or what will be the diameter of your cup, how small, or so that's an advantage in 3D. Sometimes it will help if we have already a blueprint. That way you could trace out, for example, if you already have a blueprint of the toy that you want and you just want to recreate, you could take a picture, bring it into a 3D program, and start by outlining and giving it some dimensions and scaling it to the right or the proper scale that you want. So you could either play, like over here, you could place a coin or a dog or whatever silhouette that you need to reference your drawing. So first, oh, as I was telling you before, first start with big, start with your basic layout. If you're gonna start with a big square or a big cylinder, or if you're gonna draw this one, start with the big cylinder, then you start adding all this little detail. So start big and then start smaller with the little details and indentions and all those. For example, this one, they start with this basic forms. Or if you're gonna go the other route, if you're gonna start drawing a trash can or something, start thinking on what will be the basic measurements that you see it all the time. If you're gonna draw a door, it's a rectangle. If you're gonna have a window, if you're gonna draw a football, then you start with basic shapes like a circle and then start making it an oval. And over here, I put an example of like a sheep or ship. No. Yeah, so that's the basic, and then they go all detail on even adding color, materials. So simplifying, it will be always the key. Like for complex models or for complex toys, a way to simplify will always be thinking of basic cylinders, the basic, for example, this one. If you have any picture or any object that you want to draw, either in 2D or 3D, you start extracting the basic form. So finding all the circles, finding all the squares. So if there's a sphere, a cube, a cone, and then you start identifying those. And then you take in consideration composition, measurements, proportion. But with practice, your brain starts thinking just like if you're gonna do an apple or if you're gonna do an orange, your brain starts thinking, oh, it has to be like the size of my hand, or depending on what will be your goal. But it starts with a cylinder. Okay, how do you do a cylinder? Okay, you either have a circle and then revolve it around an edge or an angle 360. So everything starts with the basic, simple, primitive forms. Form is the shape and structure of anything. It's distinguished from the material of which it's made. So I got it from, form is the shape and structure of anything, as distinguished from the material of which it's made. So if we were decided to draw a face, so this process of making a complex shape simple is not easy. That way, that's why practice is very important. So over here, if our goal will be creating the shape of a face, then we could start with this basic shape, and then we start getting more detail and defining those details more. So over here, they have a mesh. So it's also the how divine you want your mesh, like the quality. So you could see that the one at the right, it has more triangles or more polygons, or it's divided into a lot more detail. Okay, I think I have a quick video. Can you see the video that I'm playing? Or no? No, okay. Let me share my screen again.
This video will demonstrate the basic principles of 3D modeling in polygons from reference, which will enable you to model anything from a car to a character. An understanding of these principles is all you need to model quickly and efficiently. Modeling techniques are, of course, not a single set classical rule, but it's always good to try to reach the final result in the shortest way, always trying to learn how to do things as quickly and efficiently as possible from a technical standpoint. All of these foundations should follow the general rule of working in stages, starting and focusing on the bigger portions and only moving to the details after you are certain of the large surfaces. Let us start with proportions. Modeling any object is a huge time investment. It would be very wise to do all what you can to make sure that you don't need any expensive corrections later on. Take this car as an example. Even if you are very lucky and did find accurate blueprints like these for the model you are making, nonetheless, it would still be a good idea to take the effort to double-check the 3D model and to camera match it to reference photos to be absolutely certain everything is in order. It will also help you in areas which are not visible in the blueprints. In cases when you have no accurate blueprints or none to start with, you are really dependent on reference images and any measurements you have to create a rough base or layout model. Matching the bigger forms first, then moving to the smaller ones. Even when modeling objects which you don't have any measurements for, you can always use non-familiar objects to compare with. It's very important though to remember our general rule. Always start with the bigger proportions, then move to the smaller details. This alone will save you a lot of effort. For more, you can view this article to learn more about proportions. Now, once you have good reference or laid out model to build on, we can move on to perception of surfaces. One particular book we will quickly have a look at here is Betty Edwards' The New Drawing on the Right Side of the Brain. In this book, she explains how drawing is a whole skill made up of basic skills which has to do more with perception and understanding.
I think you got the basic idea of proportion because I have more videos to share with you guys. Let's see.
This video will demonstrate the basic principles of 3D modeling in polygons from reference.
Okay. Close this one. Close that one. Okay.
This video will demonstrate the basic principles of 3D modeling in polygons from reference.
Here's the video wants to play again. Okay, so next I want to talk about software. Okay, so now let's say you already practice how to draw in 2D. You already know about proportions, about how you need to get an approach, and now you want to start drawing and on 3D. So we're gonna talk about different softwares that are out there. And one of them, the one that we used on Saturday, it's called Fusion 360. And you're able to do all these different type of, like you could do a free form, you could do parametric, we could do a sheet metal, we could do direct, that means like solids, you could do a surface, and you could do a mesh. Basically, it's like you can do a lot of things in order to design a product. So I have a quick video, and let me show it to you guys. I think I got it here.
Modeling tools. Create a form in seconds. Grab vertices, edges, or faces, and simply push or pull to your liking. When it comes to the finer details, having parametrics is essential to ensure the correct form and fit, and changes propagate through the history thanks to those parameters, equations, and relationships. For some of the more complex geometry, surface modeling tools can be put to work. If you're making sheet metal parts, you'll want to use the dedicated workspace. Here you can turn those designed parts into flat patterns without complicating.
see how you can change the world with Fusion 360 and make anything. A robot, a drone, a bike, a surfboard, or an ice axe. How would you bring it to reality? Today you can make just about anything, but is your development process barrier-free? Do you need expensive hardware, specialized graphics cards, or are you forced to use Windows just to start designing? Do you need an IT team and limitless patience to simply update service packs or implement new software? Or do you need to transfer files from one tool to another? And if you do you know what's lost during the translation? With Fusion 360, let those barriers become a worry of the past and harness unrivaled breadth while you're at it. When it comes to design, Fusion 360 has you covered. With integrated freeform, parametric, sheet metal, direct, surface, and mesh modeling, you can use whichever modeling technique you prefer. Even if your design begins on a napkin, you can bring it to life using the freeform modeling tools. Create a form in seconds, grab vertices, edges, or faces, and simply push or pull to your liking. When it comes to the finer details, having parametrics is essential to ensure the correct form and fit, and changes propagate through the history thanks to those parameters, equations, and relationships. For some of the more complex geometry, surface modeling tools can be put to work. If you're making sheet metal parts, you'll want to use the dedicated workspace. Here you can turn those designed parts into flat patterns while compensating for bends. Or, if you find the history-based design to be restricting, use the direct modeling mode where we can translate, rotate, and change geometry without rethinking the history. Perfect for quick edits, defeaturing, or repairing imported geometry. Next, we'll turn your attention to the mesh workspace, where you can edit and repair those scan files, such as STLs and OBJs. The generative design approach will simultaneously synthesize multiple CAD-ready solutions based on real-world manufacturing constraints and product performance requirements. With the help of cloud computing, this technology has the ability to augment the output of engineering teams to explore the full design space of any design challenge. Fusion 360 gives you the flexibility to choose the best modeling method or methods, no matter where you are in your designs. When you've made the geometry, it's time to assemble the pieces and ensure the proper motion is captured or restrained. Assembly modeling will describe the working relationships between components with joints, such as sliding or rotation. With joints, you can limit range of motion, add cause and effect, and other relationships that are hard to create with traditional mates. Before moving forward with the design, vetting its performance with a digital prototype can help avoid wasted efforts and dead ends. That's why every Fusion 360 user has access to powerful finite element analysis tools. The integrated simulation workspace ensures seamless handoffs from the design and opens up a laundry list of available study types and failure checks, from the commonly used linear static analysis to thermal, modal frequency, buckling, and so on. Thanks to the ability to offload these time-consuming calculations to the cloud, we can solve more study types, more iterations, and the most complex simulations without effect on our local machine. These results will provide the insight required to make better design decisions. Because, at the end of the day, design is a series of decisions and trade-offs. To help with that further, there's a single point of access to discuss, markup, and collaborate whether you're on a Mac, PC, web browser, or mobile device. Fusion 360 was created with you, the user, in mind, to alleviate problematic file exchange, versioning issues, translation, and other headaches that interrupt fluid conversations. Sharing designs doesn't require a special viewer or packing up hundreds of referenced files. Instead, create links to your models that can be viewed with the browser. These links empower your customers, collaborators, or friends to rotate and interrogate, pull off crucial measurements, and even download the model in different formats, if you allow it. As great as that is, when it's time to truly document our ideas, Fusion 360 has you covered. First things first, we can start marketing our products before the first prototype is even built, with renderings. Creating high-quality images is simple, thanks to an extensive material library, advanced camera settings, downloadable environments, and the best news, we can use the cloud again to offload the rendering process. Now that we've put the cart in front of the horse, we better start getting things ready for manufacturing by creating production drawings. Fusion 360 has all the features needed to do this. You can quickly lay out views of all types, add dimensions and tolerance information, create a bill of materials, and when you're done, you can take it to DWG or PDF to share wide and far. If those drawings fall short in describing assembly or disassembly procedures, you can use animations to do that and more. Now it's time to start producing parts. Good thing Fusion 360 has toolpaths for 2.5, 3, 3 plus 2, 4, and 5 axis milling, turning and mill turn, and 2D profiles for those water jet, laser, or plasma jobs. Have a custom tool? We have a fully customizable tool library. Want to include work holding in the simulation? There's a comprehensive work holding library. Worried about tool wear? With adaptive clearing, our constant engagement roughing strategy, worry no more. Reduce setup time and increase process reliability by shifting work offsets with automated probing cycles. Take advantage of an extensive list of finishing strategies suitable for any geometry thrown at you, and generate those quickly thanks to multi-threading. But that's just for subtractive manufacturing. There's also an additive manufacturing utility. So what are you waiting for? Come see how you can change the world with Fusion 360 and make anything.
Okay, so that was that's a software that's completely free, and it covers a lot, as you could see, like simulations. It measures, like if you extract the cloud points of an object, like if you scan the object and then you get a format, it's able to fix those meshes, and you can start from scratch, as we saw on Saturday. If you missed that workshop, I'm gonna send you guys the link to it. And let's go back to our screen. So that we also talk about generative design, which generative design, it's basically kind of like how design is going to work on the future. You're going to basically get some inputs to the computer, and he's going to generate some designs, and it will create some designs during the night, and then you come back in the morning and you have, instead of having 80 designs that you come up with, you could have 300 design, or another 20% of designs that the computer thought of that you didn't think of. So there's another program called ZBrush, and basically ZBrush is, oh, I forgot to say, Fusion 360 is from Autodesk. Autodesk have another set of programs like Maya, and this will be similar to Maya. Like ZBrush, it starts with, it's a mesh, so you don't have a lot of dimensions like in other programs, like you start from a solid, but this will be the same. Like over here, down here, I have a quick reference, like you start kind of like modeling with clay. So you start with something and then you start modeling and adding material, subtracting material, but it's very organic. Let's watch a quick video. Let me share my screen.
Introducing ZBrush Core Mini. ZBrush Core Mini is a free mini version.
So they start with a cylinder.
Designed to give artists young and old the ability to experience ZBrush's powerful digital sculpting.
With a sphere.
ZBrush Core Mini contains a mini set of tools, allowing for the focus to be on artistic creation rather than complex tool sets. Starting from either a sphere or a stone block, you can sculpt from your imagination using 8 of the most popular ZBrush sculpting brushes. Experimentation is the key when using ZBrush Core Mini. Add to the surface of the model, or cut into it using brushes such as clay buildup. Smooth out areas that are rough by simply holding Shift, or even use the snake hook brush to quickly pull out arms, legs, or even hair. After sculpting, you may want to share your design to the world, or even export it for 3D printing. Choose a different material and color to give your model a different look, then click the Export Image button to export out a 2D image in various formats. For 3D printing, simply click the Export for 3D Printing button to export out an OBJ version of the mesh. After this is exported, you can open the file in your favorite slicer and print away. Now, in addition to the items already mentioned, ZBrush Core Mini adds a new way to share your creations with others around the world. When clicking the Save As button, you'll be able to save your model as an Image 3D. The Image 3D GIF and Image 3D PNG formats allow you to save your files as standard GIF and PNG images. When these images are viewed in other applications, they will just be displayed as a 2D image. However, if you open these images inside of ZBrush Core Mini, model data will be extracted and the mesh will be loaded into the software. With this technology, you can now simply save out an image 3D file and post it on your favorite website or social media account. Other users of ZBrush Core Mini can now simply download the image and have access to the model. ZBrush Core Mini is not graphic card dependent. It's free to download, and it's available for Windows and Mac OS. Download ZBrush Core Mini today and join the digital sculpting creation experience that is ZBrush.
So that was just, let me stop it. Wait. That was just, it was a quick example of the, I guess, their new tools that they have. Let's see this one. But ZBrush is really cool. Like all the things that you could draw with it, it's pretty cool. So here they start, it's like sculpting. They start with just the random shape, and then there's the extruding, making it soft, adding more material. But you could easily get lost, transform something into something that you don't want, or maybe something that you want. It's just like creating from your imagination, how far, that's why it's very important, proportion and your measurements, and that way you could, this one doesn't have audio. See, but they start big and then they start coming in with all the details. Let's see if we could. Yep. So I also have a school, like if you guys are interested in, I think I send you the interview for the guy that, let me see if I have it. This one. So that's the school, and they have created, or let me go to here. This is the school. Let me see.
It was just part of an experiment. Put some pictures up online, got some good feedback, and decided there was something in it. In movies, because like in
And then this is the interview
just was growing up in the 70s and the 80s.
The guy that
it wasn't very
founded
clear
this
that it
school.
was going to become anything. And the older I got, the more parents or adults were stop doing that and do something real.
We're just gonna watch like 2 or 3 minutes.
Very into art.
Do you remember the first piece of work that you were proud of?
I mean, I only have fond memories of drawing as a kid. I think that as far as spending like a lot of time on one, I actually still have it. It's like my parents split up when I was 9, and I did a
big painting for my dad. It's just like this like landscape with a lake and like sea serpents in the lake and like these centaurs flying in the sky. And it's this big painting that's about, you know, like 4 by 3 feet. And I remember spending a ton of time on that. I was 9, and then I gave that to my dad one day when he came to pick me up, and he framed it, put it in his office. And so, yeah.
Huh. And that was, okay, so you were 9 years old.
It's a long time ago.
Yeah. What was it that drew you to digital art?
I mean, I got my first computer when I was 9, which is really young. I got for 1982.
Yeah.
And then my best friend's uncle had an Atari 800 computer with a modem, 300 baud modem. And so I'd go to his house, 300 baud. So 300, like, you know, it's compared to today, it would be the equivalent of like 40 million or billion baud, today's internet connections. So did you see the movie War Games with Matthew Broderick, where he's like trying to hack into NORAD to find games, and the guy from Ferris Bueller's, and you're seeing the characters draw on the screen, like one character on the time when he connects to a bulletin board, or, you know, like that's what my computer was like, you know. So it was, but the point is that it was a computer, and I really got it for video games. But when I was 12, I was so obsessed with finding bulletin boards where you would find a phone number, dial in, connect to this bulletin board. This, you know, a decade before the internet. And you would connect to somebody's computer, and over that line you could type to each other, or they would have games or pirated games that you could download. And a big area that I discovered was ASCII art, which is like making art out of characters.
Yeah, yeah.
And on the Atari, it had more characters than a PC. So like if you held down, you know, you had the characters if you held shift, but if you hold control, there was a whole array of other characters. So on the Atari, you could make pretty complicated images with ASCII art. And so when I was like around 11 or 12, I got really into that, which is digital art, I guess. You know, it's simple. And I had simple paint programs. So like I would do like digital, pretty pixelated paintings for drawings on my Atari and print them out. I remember being like really obsessed with the movie Excalibur when I was a kid. So I just drawing lots of knights and swords. And so that was like my first exposure to digital art. Again, really just as a hobby for fun, you know. And then later, when I was about 13 or 14, like my interest in art,
So this is the creator of that school.
Teenager and angst-ridden, and then switched schools, and I hated the school, and I got all.
Now where that's coming from.
My name is Josh Herman. Today, I'm going to talk to you a little bit about owner programs. First, I'm going to talk to you a little bit about Number. Number was founded in 1987. It is education for careers.
Okay, got it.
And the key word there is careers. Nullman focuses on making sure that when you graduate from a Nullman program that you get a job. Nullman has consistently had very high placement rates, and the way we do that is with experienced instructors who can use their real-world training and education to help make sure that our curriculum goes in tandem with the industry. It's very common to have a teacher working somewhere like Riot, or Blizzard, or Disney, or DreamWorks, and they're teaching at their Nullman classes after their workday, which means that they're teaching you the most up-to-date knowledge and software that they're using every day in the specialty that they're working in. Now, we won't be opening our physical campus this summer term. We'll actually be hosting all of our classes online. But what this means for you is you have access to all of our amazing teachers that we would normally have only on our physical campus anywhere in the world. And online learning isn't something that's new for Nullman. Our first online class launched in 2006, and 7 years later, in 2013, we moved to a more live, interactive format that we felt would be better for you, the student, because interacting with your teacher directly is far more important to us than watching any type of pre-recorded video. Additionally, all of our foundation and our design classes are also online this term. These classes mostly focus on fundamentals and traditional art, painting, drawing, sculpting. Now, this is a lot of what we look for in our portfolios for our full-time certificate and BFA degrees. So if you're wanting to apply but feel like you don't have a portfolio that's ready for that yet, take a look at the foundation classes and then speak to an admissions advisor and they can help you out. And with this comes our custom online learning platform. This is where
Pretty cool, right? So I wanted to share that with you guys. That way you will know that that's out there. So that's for the mesh. And then we also have a very common one called called the salt systems, which is basically SolidWorks. Probably you guys have heard about it.
Desirable, convenient, and indispensable. Our everyday has been enriched with consumer products that fundamentally improve our lives. From the pioneers of industrial mass production, we've gained access to a plethora of products more attainable than ever before. Today's consumers expect better, more sustainable, connected, and more personalized products to be delivered faster, leading into the era of mass customization. And fierce global competition is forcing the home and lifestyle industry to entirely redefine itself. It's time to center innovation around the individual, accelerating progress through digital transformation. The next generation of consumer goods are brought to life, satisfying demanding individuals with even more desirable personalized experiences, tailor-made for their specific needs, beliefs, and convictions. Enhancing the real world with the virtual world. The Soul Systems 3D Experience platform empowers home and lifestyle businesses to imagine, simulate, create, and launch products to market faster, connecting the entire value stream, from design, engineering, manufacturing, and supply, to marketing, sales, and logistics, into a single collaborative environment, enabling the perfect personal experience for the modern individual consumer, harmonizing product, nature, and life. Future possible by virtual universes. Experience the future today.
So SolidWorks is another powerful one. It's all around the world. And they are able, like John Deere uses it. A lot of car industry and a lot of assembly parts, they go into there, and it's from Europe, the company, and it's very common. You guys might recognize the logo, or you might guys have already used it. And it also has simulations. It also has a lot of materials that you could do, rendering, assembly. And it has surfaces and solid and drawings and assemblies mainly. And let's continue with our presentation. Okay, so let me see what I have. I think we already went to that one. Concept art, mechanical engineer. Let's see. We're kind of like running out of time. So I wanted to show you this last quick video. So a live on a mechanical engineer. So this will be, I think it's like 4 minutes long, but we'll see if, or we'll see how long is it.
My computer's possessed. The numbers are literally changing right in front of me.
David, it's a shared document. It's probably my gun finance.
Man, it's everywhere.
We're changing the design. I thought I could do with a little more thing then. No.
Your call's coming over.
Got it. Mine's coming on. I'm wearing pants.
Build custom industrial machines in days.
Hey, so my name is Jess. I'm a mechanical engineering student, master's student at ETH Zurich, and today I'm going to be filming a day in the life of a mechanical engineer. Because looks like a lot of people are hungry to see it, and also today I get to do experiments. So usually I do a lot of simulations, which you will see later, but today I get to do experiments to back up my simulations, which you will also see later if I get permission from my prof. Also, if you're wondering, no, didn't go.
Yeah, sorry, it's 8 minutes long, so I make it. I'll try to make it too.
Pretty big. And so this is pretty much what I do. General Electric, Swiss Air. Cool, huh? Hand for scale. Okay, so I'm in my office, and I'm going to show you some of my simulation. So, there we go. So this is the first flame. Yeah, this is like the temperature of the flame. So the red part is the hot part. Here we have the oxygen, and then here we have the fuel. So obviously when the fuel burns, there's no more fuel inside the flame. So that's why it's white on the inside. Same with the oxygen. It's blue on the inside because there's no oxygen once it burns, because we're burning fueling. And so this is my first flame, and now I'll show you my second flame. So now you can see my two flames. So this is the flame I just showed you. It's kind of going crazy here. Here I have extra air coming in, and here I have extra fuel coming in. And because the flow is so hot, there's this second flame that's forming. So you can see it's kind of like a dragon. And so it's pumping, and this is an instability. So do you see that? I should be looking at the camera. And here's my supervisor checking on the test rig. I didn't want to use my own footage because I didn't want to get in trouble, so this is the footage from my lab's website. Pretty much, I don't know what you want me to tell you. I just finished the experiments. Now I'm extracting data, gonna put into a presentation. Pretty fun, life of an engineering student. So this is the Messung von der Verweilzeitdeck. This is the test rig, and here we have the second flame. And so these two flames interact together, and they create like acoustic modes. And so this is the test rig that I am simulating right now. So I'm simulating it here. You can see that this is a flame. So this is exactly what I'm simulating that I showed earlier. Or this is another way to visualize the we run out. So, and on top of that, wind and solar are very sporadic, but this is the demand. So this is constant, but renewables are not constant. So we have to figure out a way, which is gas turbines and burning gas, oil, and coal. And we have to use these pretty much to make, in order to do that, we have to investigate the two flames in the burner, which is what I'm doing. And that's it. Yeah, pretty much. That's my life as a mechanical engineering student at ETH Zurich. That evening, I didn't really do much. I came home, I ate a salad, and then I watched Parks.
So I thought that was pretty interesting how they simulate the flame. First, they have to draw it at the right scale dimensions, and then they simulate the fluids. I don't really know how which program they use and all that, but I just wanted to share how they use for example, for this one, they use the simulation, and then they use to extract data and make conclusions. That will be the same as our statistics. We kind of like have our sample, and we wanted to draw some conclusions from our sample to make for our population. Let me see what we have. And Okay, I share that with you. This is another quick video of how they start or how they did Toy Story 4. Let me see if you guys get to share.
It's never been more important to stay up to speed, and suddenly can help with 100 meg internet on our next generation network. Stay connected anywhere in your home for just... If you've seen Toy Story 4, you've probably noticed that Pixar's animation doesn't neglect any detail, no matter how small. From dust particles in the antique shop to subtle signs of aging on the toys, it's all there, rendered incredibly realistically on the big screen. So how exactly did Pixar bring this intricate world to life? Let's take a look at the fascinating process that created Toy Story 4, from start to finish. For Toy Story 4, as for all Pixar films, story comes first. While the writers draft the script, story artists work alongside them, making preliminary sketches for each scene in the film. These sketches, called storyboards, give the Pixar team an idea of how each scene will go down. Editors then cut the storyboards together into an animatic, or story reel. Basically, a long, detailed flipbook that reflects the pace of each sequence. The story reel is edited with rudimentary sound effects, a scratch soundtrack, and temporary dialogue that's been pre-recorded by Pixar employees. It serves as a rough draft for the movie, allowing the filmmakers to get an idea of how the story will unfold and hone the sequences before having them animated. Once the storyline is set, the art department and production designers get together to create concept art for the characters and their environments. Meanwhile, character artists lay out how each toy will look in the film. For Toy Story 4, character design involved a lot of research into the toys themselves, how they're made, how they age, and everything in between. The character team found their perfect villain on field trips to antique shops, where they'd often spot vintage dolls lurking in corners. There, the idea for Gabby Gabby was born. This newcomer is a talking doll from the 1950s, and she's designed to come off as very toy-like, in a way that might even give you the creeps at first. On the other hand, it's all warm fuzzies when we meet Ducky and Bunny, a pair of carnival prize toys voiced by Keegan-Michael Key and Jordan Peele. Their loud, bright colors, cheap-looking plush, and sheen finish were designed to look authentic for the kind of toy you'd win at a carnival game. Not the highest in quality, but lovable nonetheless. The character artists also act and emote in precise ways as the story requires, so the characters can now move, and they...
This is Webflow. Meet the design tool from the future. The most powerful...
They have sets to move around in, but something's missing. Neither the characters nor their sets have any surface characteristics, making everything kind of fall flat. That's where shading, or surfacing, comes in. Shading artists' job is to furnish the 3D models with the kind of textures, finishes, and tints they'd have in real life, lending them visual complexity and charm. Some of this work is done using shaders, computer programs that know how to simulate a range of materials, like plastic, fabric, metal, wood, glass, hair, or skin. Clever software proved useful for the 10,000 items that filled the image. And of course, Rey from Star Wars. In contrast, animators gave Gabby Gabby more doll-like movement that'd be consistent with an old-fashioned pull-string doll of her variety. Her weighted eyes blink slowly, closing when she's horizontal, and she mostly moves from joints in her hips, shoulders, and neck. While the animation team choreographs characters' movements and facial expressions by hand, the simulation team uses computer programs to lay down the movement of other elements, like fur, weather, or clothing.
Pretty cool, right? Okay, and what's a design engineer? Let's watch this one, and then we're gonna be pretty much done. Well, not done. Let me see. Okay.
Design engineers work hard to solve problems. They often share certain characteristics which make them really good at their job. Frustration can be seen as a bad thing, but for design engineers, it can be the starting point for a really good idea. Identifying what frustrates you about an existing product can help you make it better. A successful and well-designed product is something that's easy to use. James Dyson's frustration with the vacuum bag encouraged him to rethink it and use a cyclone design instead. Wrong thinking is allowing yourself to think differently and to not be afraid of trying new and crazy ideas. Keeping an open mind can lead to a solution that no one has ever thought of before. It's about thinking your way around a problem and seeing solutions that other people might not. To answer his brief of creating a small car that could still carry 4 adults, Alec Itagonis decided to put the engine in the opposite way round. A perfect design doesn't happen straight away. Design is a process. When something doesn't work first time, it's about sticking with it, making small changes, and ultimately making your design stronger.
5 years developing his first vacuum and made more than 5,000
You have to learn from things that went wrong, work out why they went wrong, and using that experience, find out how to make them better. It took Thomas Edison thousands of attempts to invent the light bulb, and now it's still used by millions of people every day. Mm-hmm. All new designers need to have a bit of fighting spirit and be prepared to keep going in the face of competition. If you're designing a new product or improving someone else's, you'll have to convince people that your product is better. You'll have to explain your product clearly and talk passionately about it. Design engineers need to be determined.
Okay. I just want to end our class with this video, which is kind of like the mistakes that some people have.
One way to do it. There are multiple ways to do it, and the more of a fundamental understanding.
So it says it's called the biggest mistake every artist make. So it's just kind of like there are some quick advices now that you're young and you're just starting your career. That way you have those in consideration before.
Get a real-time bird's-eye view of your project.
I just wanted to share
Create
them.
project plans in one click. See the big picture across multiple projects.
Can you guys see my screen?
Gain of a subject like that, the better, faster, and more efficient you become. So what are some actual differences between them? Like one of the bigger ones when it comes to basics versus fundamentals is that.
Let me just start it. It's a basic.
How would you like to help local
mistakes in the fundamentals of 3D design, 2D and modeling. So that's why I like them.
Yeah, this mistake sort of, there will always be a ceiling cap to the skill you can reach if you don't correct this. And it's something Henning and I have both done. It's something that you will continue to do at some points throughout your career, but there is an easy fix for it. So let's get into it. So what we're talking about in this video is basics versus fundamentals. This sounds like a topic which is about grammar, where you're just talking about the word basics versus fundamentals. The reason we're talking about it is because people assume that this is the same thing. We keep talking about we're going back to basics, we're going back to fundamentals. But this couldn't be further from the truth. We are not going back to basics and back to fundamentals. They're completely separate. They're completely separate skill sets. And it's really important that we define what these are so that you can really optimize your learning journey. Yeah, essentially, these two words are what we've coined the concepts that we'll be talking about. And like in broad terms, a basic skill, the way that we're defining it, is a skill that you can master. It's a finite skill. It's you opening up a piece of software, learning where all the buttons and what all the menu items do. Or whether it's you pick up a camera and you get familiar and learn what all the buttons on a camera do and what every little menu setting does. Then there's the fundamentals. Fundamentals is a skill that you can essentially never master. It's a limitless ceiling. It's something like color theory. It's cinematography. It's the fundamentals of figure drawing, like gaining a true understanding of these concepts. That is what we're defining as fundamentals. This is something we've seen essentially every single artist struggle with. Morten and I, we come from a 3D background where we've been learning very technical software. And you might come from a completely different background, but the skill set and the path is going to be very much the same, where you start to learn the software and you get better and better and better. Your art improves as you get better, as you learn more features in the software, or maybe it's a camera you're using. Regardless of what it is, the medium you're using, you're getting a better understanding of how it works. And your art gets better linearly with how much better your software skills becomes. But then you reach a point where you get feedback on something that you don't understand. Suddenly it's not about, oh, just enable this feature and just duplicate the layer and do this weird trick. The feature or the feedback you're getting is, you don't know how to compose the image. And you're starting to realize that your issues have nothing to do with the software. Yeah, an example of this was when I was first getting into digital painting. I had never really drawn much in my life. I'd sketched on paper.
Can you guys see my screen?
So I started getting into digital painting.
Yeah, that's what I thought. Let's see.
And I mean, at that point, I'd been.
Okay.
Using Photoshop for, I don't know, 8 years, I think. I was very familiar with Photoshop. Buttons, like we talked about the UI. I could find pretty much anything and I could follow any tutorial. Getting started on painting. And I remember this clearly. I followed a tutorial by an artist, Richard Anderson, concept artist. And I think it was called like the Forest Horseman or something. It was a guy on a horse and like this really strong composition with a log and like trees pointing towards him. I showed it to a friend of mine. And at this point, I really didn't have a grasp of any kinds of fundamentals, just the basics. And he told me that it's really good painting and I love the composition in this image. I had no idea what he was talking about. I just said, thank you, and moved on. And it wasn't until years later when I started digging into the concepts of color theory, composition, lighting, mood, that I really started to understand why it was he complimented me. He wasn't complimenting me. I had just replicated what Richard Anderson had done. But it wasn't really anything to do with my skills at that point, which is kind of interesting. We both went into this trap of learning the basics. I had a similar story where I was doing a 3D model and I was blocking it out and textures looking nice and all that. But I couldn't figure out the composition. This is where I was aware of that composition was a thing. I just had no tools on how to do it. And this was right before we went to school. This is where Morten and I met at the animation workshop. And that focused heavily on the fundamentals. But I didn't know any of it. If I had progressed on the path I was on, I would have known every single button of my 3D software. And I wouldn't have known, if my composition would have still remained the same. Maybe I would have had less noise in the render, and the render would have been faster. But by only focusing on the basics, you are only getting to the same result faster. Yeah, I think it's important for us to also mention that when we say basics, we're not necessarily talking about something simple. Like you can have, as strange as it sounds, advanced basics. If we take programming as an example, right? The basics of programming are the same or like they change depending on the language. It would be like the specific syntax of one language, which variables to use. How do I combine all of this? You can read an encyclopedia of everything when you're programming in Python, for example, and know every single thing you can write in Python. But the fundamentals of programming go deeper than that. That is learning to think like a programmer, problem solving, the different ways you can solve like programmatic issues, like what is the most efficient way to loop through these things? There isn't just one way to do it. There are multiple ways to do it. And the more of a fundamental understanding you gain of a subject like that, the better, faster, and more efficient you become. So what are some actual differences between them? Like one of the bigger ones when it comes to basics versus fundamentals is that basics change over time, while fundamentals are timeless concepts. Your understanding of color theory in the 1500s are still valid today, but your understanding of software from 1999 are absolutely not valid today. It's so important that you think about these as timeless concepts.
Yeah, where what we've talked a lot about, like trying to dissect this topic before recording this video was a very philosophical discussion of what are these things. One of the things we talked about was, as we mentioned, these are names we've given to these two concepts. You need to develop an understanding of the concepts. We could call it red and blue. We could call it lamp and wall, or basics and fundamentals. It's two different concepts within learning. You can't have one without the other. Like, you can't only understand fundamentals. Like, if you only understood the fundamentals of, let's say you're a digital artist, right? You want to paint or something like that, or a traditional artist. If you only understand the fundamentals of color mixing, color temperature, composition, lighting, so on, but you don't have any basics, the basics mean that you won't really know how to pick up a brush and know what to do with it. Like, if you're painting with gouache or if you're painting with watercolor, fundamentals kind of stay the same. There are nuances in there, but if you don't have the basic skills to actually paint, if you haven't trained your hand-eye coordination yet, the fundamentals don't mean anything, and vice versa.
It's not about which one is the most important. They're both important. It's about the balance of it. And it's about learning the basics to a certain point where you're comfortable with the software or technique. And then it's about focusing on the deeper fundamentals as you go along. One of the ways of figuring out if it's actually a basic or fundamental skill as well is asking if it's a how or if it's a why. This is something we have all the time. We're talking about 3D, which again is our background, which is like, how do I add a cube? So you click on the cube. And then you go into like, okay, how do I add a light to it? So you click on the light. Okay, so now you can add light to the cube. But then you're like, why did I add the light? Well, it's because you want to get a certain mood across. Maybe you want it to be scary. Why does darkness feel scary? Well, let's go into if you stuck in a forest 2,000 years ago and it's pitch black. Why is that scary? Well, because there might be something hiding there. Why is that scary? Well, because it can hurt you. And now you're going into topics like biology, psychology, history, anthropology, all these kind of things, where this is where you're getting into that basics is finite. You have a finite amount of ways of doing a task. There is a finite amount of ways of adding the cube. You can have 3 ways of doing it. But when it comes to the fundamental of why you're lighting it in a certain way, you can literally write like all the books in the Oxford Library to get to the bottom of this, and you're still not going to be satisfied. Of course, you shouldn't, but you could. It really spelling mistakes in every single word. You get trashed.
Yeah, it's actually an interesting point. It reminded me of my mom. She currently finished. My mom loves writing. She loves writing. She's done it, I guess, all her life. But she told me recently that in terms of grammar, she's terrible. She doesn't know anything about grammar. But she recently was a part of a project where I think it was like a collective of 20 people, and they would write stories about a certain subject. And, they take her part of the story, and then they send it to an editor. She describes her experiences, and I haven't, they might be very emotive and invoke certain feelings, but that doesn't mean that just because the grammar isn't there that you don't understand the feelings he's trying to get across. So you can still be an amazing writer even though you don't really understand the basics of grammar that way.
Yeah, or you have a problem with it, for whatever reason it can be. It really just boils down how important the pure fundamentals are. Because let's say that you have an essay and it gets like a 10 out of 10 because it has perfect grammar and perfect spelling and all that. But the story is boring. But on the other hand, you have a story which is beautiful, tons of errors. Fix all the errors, you have a beautiful story. The other one is already perfect, but it's a terrible story. The fundamentals just isn't there in that story.
making sure that your fundamentals are strong, I definitely believe makes you more hireable and more versatile as an artist compared to someone who just knows the basics.
Yeah, we've seen this all the time when we worked in film. For people who are new to our channel, we worked in the film industry in London for some years, and that's a skill which is highly technical, but it's highly technical, but it's like technical. I don't know, like 6 months ago.
Pretty cool, right?
I see this a lot when artists get more and more advanced into their field. They become a lot more philosophical in general. Yeah. It's more about why do I do?
Fundamentals can never really be mastered. They are very subjective. There's something that your understanding or my understanding of a certain fundamental skill, let's say composition, is different from Hennig's. It's different from yours. And that's what makes it tricky.
And by focusing on fundamentals, you will improve your art significantly. You will be ready for the change which happens in the industry, whether you get fancy machine learning tools or whatever it might be. You will be ready to weather the storm of time.
If you only have basic skills, you are in much more danger of losing your job versus if you have basic and fundamental skills. Because the fundamental skills, like we said, kind of transcend time. Bernini's sculptures from the 15th century, 1500s, I don't know, is like, they still look good today. They looked good back then. They will look good in 1,000 years because there are good fundamentals.
So if you want to see more content like this in the future, make sure to like, comment, and subscribe. And we also, Emily.
Okay, guys, so that'll be it for today. And it's pretty cool. If if you want, I could share all those videos that we saw today. And as you can see, start young. It doesn't start like you're on an advantage because you are pretty young and you could learn whatever you are interested on, and it'll be worth it. Make you have advantage from your teammates because you get your brain working, like your brain to adjust to seeing objects in 3D or learning the light, learning the colors. So I'll advise to continue what you're doing, continue to be like right now, like in STEM, continue to do to focus, to learn more. And thank you guys for your time, and I hope you enjoy the rest of your evening, and see you next Thursday. Thank you guys. Bye. Bye, Camila.